Good day to all. Today we are going to see about the series and parallel circuit. See, this is the series circuit. This is the voltage, and here it resistance 1 R1, and this is R2. This is resistance R2, and this is resistance R3. The connection is in series. In a series circuit, the current flows through each components is the same, and the voltage across the components is the sum of the voltage across the each component. That is the main thing. The current is same, but voltage is sum of the each component across that circuit. Then the parallel circuit. Here in that parallel circuit you will see here the connections and resistance 1, resistance 2, and so on, resistance n. These resistors here, these resistors is in that parallel connection of each other. This R1 is parallel with this R2, and this R2 parallel with this Rn. So the thing is, in parallel circuit, the voltage across the each components is the same, and the total current is the sum of the currents through the each component. Whereas in that series circuit, current is same and voltage is sum of the voltage across each component. Here in the parallel circuit, the voltage is same across the each component, but the total current is equal to sum of the current through the each component. This is the main difference between the series and parallel circuit. Here in series, current is same. In parallel, voltage is same. So, in series circuits, a series circuit is a circuit in which the current can flow only through one path, and a current is in same at all position in a series circuit. Whereas in parallel circuit, in contrast, in parallel circuit, there are multiple paths for current flow. Here there is only one path for current flow, because you will see the previous diagram. Here there is only one path. This path is only there. So there is no other way to flow the current. This is the only path. So there is only one direction here. Whereas in that parallel circuit, there are multiple paths. Here the current will flow this path, the current can flow, and this path also current can flow, this path also current can flow. That is the thing saying here. For current in series, it has only one path, and in parallel it has a multiple path. Then the different path may contain different current flow. This is also based on that Ohm's law. What is that Ohm's law? We will see that Ohm's law detailedly in upcoming videos. Then here the total resistance will be lesser than the smallest resistance. This is the main concept over here. See, if the resistance, there are two resistance over here, resistance 1, resistance 2, and resistance 3. These resistance, which connections they are? They are in that series connection. These resistance are in resistance 1, 2, 3 are in series connections. So what we said, For series connection, current is same. Voltage is sum of that each component. But the thing is here is the current is same. So if you want to calculate the total resistance of the particular circuit, we have to add all the resistor. If there is a 3 resistor, we have to add resistance 1, resistance 2, resistance 3. If it is resistor 5 means we have to add resistance 1, 2, 3, 4, 5. Likewise, if we need a voltage means we have to add all the voltages across to the resistor. If there are 3 voltages means we have to add voltage 1, voltage 2, voltage 3 like that. Then we will move to that parallel circuit. In a parallel circuit, the voltage is equal. So if you want to know about that resistance, total resistance, the formula for the total resistance is 1 by total resistance R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by Rn. So finally we will get the value of that 1 by R total. If it is the total 1 by R resistance total is 1 by 10 means what will be the resistance total? Total resistance will be 10 by 1 which is R. Likewise we will find out the total resistance of the circuit. Then how we calculate the total current in that particular circuit? We just add the all current across the resistors. R1 plus R2, I1 plus I2 plus I3. Likewise, we will add the total current of the circuit. If we want to find out the two resistors, if the two resistors are in parallel, what will be the formula? See here, if there is only two resistors, R1, R2, here one resistor and also here one resistor, two resistors are in parallel. This is R1, this is R2, this is R1 and this is R2 means what will be the formula? Now we have to find out that formula is that R total equal to R1 into R2 divided by R1 plus R2. This is the formula for parallel resistance over here. That's denoted here. To find out the parallel resistance, the formula for that R1 RT equal to R1 R2 divided by R1 plus R2. Likewise, we will find out the total resistance of if there is only two resistors. See, you can see here, this is just a pictorial presentation of series as well as the parallel circuits. If there is a water, if it is in series, the resistance will be R1, R2 like that. It will come seriously. If it is parallel means the in series R I also will come in same path because there is a no other path for that current I. If it is in parallel, it has a three divisions like R1, R2, R3. Likewise, current will also differ like I1, I2, I3. Then the advantages of a parallel circuit over series circuit is mainly each device in this circuit sees the full battery voltage. That is the first advantage of this parallel circuit. Then the second one is each device in the circuit may be turned off independently without stopping the current flowing to the other device in a circuit. Why? See here, if it is parallel and this is parallel, see three resistors are connected with that parallel. What we are saying here, each device in the circuit may be turned off. If we are turned off this circuit, it won't affect the other circuit also, because the current will flow here, right? If this is the parallel circuit, here one circuit is there, here one there, here one there. If there is a cutoff over here, if there is a cutoff over here, means the current will flow this path. So easily we can have this parallel circuit. This is the main advantages of this parallel circuit. Each device in the circuit may turn off independently without stopping the current flow to the other devices in the circuit. That's all about the series and parallel circuit. Thank you.